Hello and welcome to another great tutorial on beginning C. This is part 24 and we're going to be talking about reading a text file. So in any program that you write, any kind of computing, you need input and output. And there's different ways to get input and output. You can get input from a user, or you can get input from files, or you can get input from other programs. In this case, we're going to be getting input from a file, and this type of file is going to be a flat text file. It's comma delimited. And so the other types of input, for example, binary files, if you have things like JPEGs, Word documents, zip files, all those other types of files that you can't open with Notepad, those would be your binary files. And sometimes there's open standards and sometimes there's closed standards, as in the case with many files that you may be opening, but you need a program that can understand those binary files. In the case of text file, anything can really read it. Any text editor can display it. And a lot of times you have data stored in flat text files. And in this tutorial, we're going to be talking about how to read a comma delimited file or a comma separated file. We can name it anything we want, but as you can see, we'll name it .dat in one case and CSV in another. So let's get started. So in order to read a file, you need to do a few things in C programming. So in this case, we are going to do it a couple of different ways. So in order to read a file, we need a string and we need the file pointer. This is defined in the stdio.h library, and we can call this anything we want, but it has to be a pointer, and we just by default set it to null. In this case, what I'm showing you here is, if you remember from the other tutorials, and you might wonder why I waited to do that before this, is because here we're taking arguments from the command line, and we have our argc and our argv. If the argc, in other words, the arguments are greater than 1, remember that the first argument is always the executable. So if it's more than an executable, we can say that this program was called with another argument, and we assume that argument to be a file name. In that case, we can use that as the file name and we open it. So how do you open a file? So you have the pointer, you call fp, and you call this, which is also defined in the stdio.h library. We call the file and we open the file. Now we can put any path here. This is in Windows, we do the path like this. In another system, like if you may have Linux or Unix, well, you use the / and you don't have drives like this, so you would actually give it the path. Whatever path you have is valid, and you give it the file name. And the second parameter here is simply to tell it what you're doing with the file. You can open for read, write, append, and you can open up for both read and write, append and write, and so on. And you can open up binary files, but we're talking about text files and we're just talking about reading, so we use the R. For write, it would be W, and we will cover writing in the next tutorial. So I've modified this a little bit, and I've been working with it, and I decided that I didn't like the first video, so I'm creating another one, and I may have some garbage in here. So I know, for example, I have this garbage left over from that, and let's see, get line, close. Everything seems fine. And as always, I like to code and go. In this case, I just went ahead and got started with the file because that gives us a better way to start it off. So I have the file here. I'm checking to see if I have arguments. If I do, I use that as my file argument. If I don't, I just use a path. I have a file stored in C dev temp students. Now, if we go to my directory, if I go to C dev, that was not a good way to do it. Thought of the command line, so let's see. So if I go cdev and I go to temp, you can see that I have the students file there, and that's what we're going to be reading. And you can see my path is cdev temp. Notice that Windows uses single slashes, but I'm using double slashes, and the reason for that is because in C and most other programs, a single slash indicates an escape character or escape sequence. So if I only had one slash, it would think that I'm trying to escape the / with D. That's why I need 2 slashes. Now when I pass it as an argument, it automatically does it correctly, so I don't have to worry about that in that case. So I open my file, open it for read, I create a variable that is 100 characters long. Now the proper way to do this would be line to define. Let's go ahead and do that for good practice. Right? And we say 100. And as always, you would have line len plus 1 for the null character. Now our file's not going to get that long, and in all actuality, we would actually have the file, we would have to know what the maximum length is and what those elements within that file would be. If you want to look at the contents of that file, I have an exact copy here, and it has a different name, and this is what's in my file. In my file, you have first name, last name, age, GPA, we have the street address, we have a city, and we have state, and we have a zip code. Now notice that my files, all my elements are delimited by a comma. So I have Joe, comma, Smith, comma, 17, comma. That is so we can break the file apart. We can have variable lengths. As long as we have a comma separating everything, we can now separate it when it comes time to read the file in. So you can also have fixed length records where instead of having Joe here, for example, you might actually have 30 characters with a bunch of blanks, and so that's called a fixed length file, fixed length record file. But this is a comma delimited file, so we have the comma as the delimiter. And it would be illegal to use comma in anything else because it would create problems. So just make sure you do that or keep that in mind when you have comma separated files. So let's go back to main C. Let's see if this even works, because I've been playing with it and it might not. So let's see that file. It opens. We have a line length. Here we check to see if we actually got a stream. If we have a null pointer, that means that the file was not able to open. Now, why wouldn't it open? It could be for many different reasons. Maybe the file does not exist. Or maybe the file, you do not have access. In many systems, if you don't have access, for example in Unix systems, if you don't have permissions to read, you will not be able to read and you will get a null pointer. And so we check for that first, and if we do, we print a line saying print the contents of the file, and then we turn around and print each line. So we print the line, and let's go ahead and print a return after we come out of here. Well, actually, let's print it here for every line. Let's print it at the end of the line. Why not? So let's print a return character at the end of the line. We display what came out of it, and so we're just taking the line. Now here you notice we get fgets, and that's also defined in stdio.h. So we have fgets. We pass in the variable for line, and it's going to store the value that it reads into that line, and then we tell it to read. In actuality, we would tell it to read line length, so we can do that here. We just say line len, and we pass it the file pointer. That way it knows where to read. And then we say not equal to null. That means that if this does not read anything in, it's going to return null. It means it has reached the end of the file. There's nothing else to read. If there is no lines in there, it may just return null from the get. So we have to always check for that. If we did read the line, it'll store it in line, and we just display the line using our usual formatted string and printf, and we display it. So I think we have everything to read a file. Let's go ahead and take a look, see if it works. So let's go ahead and save first of all. So we save the file. Let me clear my screen because I was working with this earlier. So where am I? Let's check, let's see what we are. Let's see, we have the file in here. So we have the main.c. That's what we're after. Let's go ahead and compile the file using our compile command, gcc-o, the name of the file, and we can give it a different name, rf1. Well, let's just call it rf because I'm already using that in rf, and we tell it what file we want to compile, in this case main.c, and it compiles with no problem. Let's run it now, and you can see it gives us the contents of the file. Those are the contents that are stored in the file. So let's go ahead and clear our screen, and like I talked about earlier, if you have the other file, you have, if I pass it argv, if I pass it a file name, it can read that. Right now, one thing that I didn't do, and let me go ahead and do that, and let me just say what file I'm reading. Printf %s, and let's pass it our, whoa, we won't do that. Let's do this. In this case, it's reading the file that was passed in. So we'll say argv1, because remember the 0th element is the name of the executable. So we want the element 1, not element 0. So we want to know what file we're reading. And in this case, let's also print it down here. And in this case, we are going to simply say reading file. We can copy this here, and we don't need to use the variable. And let's get rid of everything here. So it tells us it's reading such and such file. So it's going to tell us which file it's reading. So let's go ahead and save this. Let's go ahead and run it again, see if it works. Let's just go ahead and do this. And it tells us it's reading student CSV. Now what if we pass it the argument dot. In this case, it's telling us it's reading file dot. So there you are, it's reading two different files. How do we know they're two different files? Well, if we change, for example, this one, and we add another value, and let's just add Beth Mullen. Let's say she's a senior stellar and she has a 4.0, and we can leave everything else the same. So because we're not even reading the rest of this, well, we are reading everything, we're reading the entire line, but let's just leave it the same. Say D3. Okay, that's good enough. Okay, so let's save it. So we save this file, and this is dot. Now you notice when I just run the executable, she's not showing up. So we have all the way up to John Gonzalez. Now if I read the other file, oh wow, it would have been easier for me to just type the read file exe and data. And you can see she's in this file. So let's do that. But at this point, this made me totally meaningless because, well, what do you do with that? You read a file, great. You displayed it, great. What do you do? Okay, well, normally you want to read a file and you want to take the data apart and you want to store it. And then you may want to do something else with it, create some kind of records, perform some kind of logic, maybe examine their GPAs, maybe feed it to something else. So this hasn't taken the individual elements apart. It's just one big long line, one big long string. So since it's comma delimited, we can do it very easily. So let's go into main.c. Oh, sorry, wrong main. So let's go into main.c. And what we want to do is we want to break the file apart into records. So how do we break the file apart into records? Well, if you have records, you remember from previous tutorials that we have something that fits perfect for records, and that is the struct. So let's create a struct. And let's call it student. And for student, we can take the file and say, let's create some variables, first name, and we can make it 30 long. And to keep with good practices, we would say define name length, and we just make it 30. And we could say here nameLen +1. And we have something for last name. And we could say nameLen +1. And keep in mind I'm doing the +1 if you remember for the null character, because if my name really needs to be 30 characters and I want to store 30 characters, I need one additional character for the null character. Otherwise it would get truncated. So I have that, or it would write into a location it shouldn't be writing to. And then so we say, next thing we say an integer for age and a float for GPA, because we want to display, 3.9, 3.7 and so on. So we want to float there. And we have this type diff. And actually I did this wrong. It should be struct and then the type here. And there we go. We have a struct. One of the first things we want to do is, okay, we want to store the data in the struct. So one way we want to do it, let's just create our API. We have this line and we can say read the line. So how do we do that? We can create a student. So we have a student there. And keep in mind, I could read these into individual variables. I don't have to have a struct. I can create individual variables. So for example, if I wanted to have a name, a first name here, I could say first name and then create all individual elements. But since a struct organizes it much better, let's just create the struct. And so we say student, and we have a student now. And we can take the line and we can say student equals read student. And it's not really reading, it's just going to say parse student. We just say it's parsing the student, and we have to pass it the line. So we pass it the line and it's going to give us back a student. So we do that, and so we take that and then we want to display student. So we create another function called display student, and we pass it the student that we read in. So we do that, and since we do that, let's play lucky and not even bother displaying that line, because we're going to read it into student and display student. And so let's go ahead and do that. We have to create the function parse student. So in order to parse student, if you remember from previous tutorials, that we use the string token function, and that can be found in the string.h library. So we say student parse student, and we pass it we don't want to modify our line, so we pass it that, and we say line, and then we have to take our string talk. So we have a delimiter. It's comma delimited in this case, so we need a delimiter first of all. So we can say char, and we can say delimiter, and we have to have a length. So let's say delimiter equals, and we can say 2 equals, and we just pass it a comma, and then we need a student, and we name it student, and of course we have to return the student and fill in the details. So in order to fill in the details, we have to have the string talk function, and in order to do that, we need a character pointer for the token. Okay, and the token we can call string talk. I believe that's it. So let me see, I think I have it wrong. So let's see, string talk, and we need to call it with the string that we have. In our case, it's the line, and we need to pass it the delimiter. So we have the delimiter there. And if it gets us something, it'll give us not null. So we can say while token not equal null. And null is defined in I believe it's defined in several places. I think we have enough it's defined in maybe string age, or I believe it's there. It's defined in several places. I think we're covered though. So let's see, while token not equal null, and we want to take in one of the things that we need, because we need to know what element we're on, because if we just go through the tokens, we can certainly get the values, but we need to know what token we're on. So because the comma is the file is comma delimited, each element in between commas is basically an index. So it's going to read it from left to right. So the first element is 0, second element is 1, and so on. So let's create an indexer for that. So let's create an index, and we just say I equals 0. And of course, as we're reading, we have to say I plus plus. And we have to keep reading. So we keep reading and we say token equals string talk. We keep reading and we call string talk, but this time we call it a little bit different. If you remember from the previous tutorials, and we say delimiter, we pass it the delimiter, and since we took and read string talk initially, we read string talk, we already have a value, it's there. So the first value 0, so we can say if I equals 0, we're at element 0, and we can take and copy that value into our student. So that the first value is, string copy, you can say student and first name. We're going to copy that value into the first name, and we can say the same thing for the next element. The next element will be element 1. Okay, so that's the next thing in the token. So this time it's last name. So we can copy the token into the last name, and then we have another one, and the third element, which is element 2, because it's 0, 1, 2, 2 with 0 base. So we have that, but we can't do a string copy this time. We can do a string copy, but we just can't copy it into our struct age because that's an integer. So what we need to do in this case, we don't use string copy because you don't copy like that into integers, and we say age. And we can't say equals token. We can't do that because you just simply cannot copy a string into an integer. So what do? Well, there is a function in, I believe it is a standard library. I'm not sure which library it's in. And if it's in std.age, I believe it's in stdlib.age. So let's go ahead and include std.age. And if you're ever in doubt, not string. If you're ever in doubt where these functions, where these libraries are, there is an awesome site to find. For example, let me go ahead and show you. Oops. And make it smaller so you can see it. Let me make it smaller. So there is an awesome website, and I usually just say, for example, let's say I'm looking for, what was I looking for? String talk. No, it wasn't string talk. Let me see what I was looking for. Oh, A to I, that's right. So I'm looking for A to I. So I'm looking for A to I. So I look for A to I and C. And tutorialspoint.com, it's really awesome because I can look up A to I and it tells me what the API is, and it tells me everything about it, and it gives me an example of how to use it. But the other cool thing about it is it tells me what library it's in. So you can see here it's in stdlib.h. It's highlighted, and you know that's where it is. Let's close that. So we have A to I, and that's going to convert a string into an integer, and that's an integer. So now for the final piece, well, I can't copy, so let's go ahead and do this. I have a sticky mouse and it gives me problems. So if equals 3, we can say student age, not student age, student GPA equals A to F. And A to F is similar to A to I. A to I converts a string to an integer, and A to F converts a string to a float. Of course, the value has to be something that can be converted, right? Because we know that in ... our age is an actual integer, and this one is an actual float. So if I was trying to convert Smith, for example, it'd probably give me 0. It wouldn't be able to convert anything there. So just keep that in mind. It has to be actually a string, but it has to be numeric. So we have that. We're reading, we're parsing, we're reading the student, and we increment the I. We keep reading until we reach the end. So we have the student there, and we just return the student. So that's for parsing the student. Now let's display a student. So we want to display the student, and very simply we can say void print student, and we can pass it the student. And this makes it a whole lot easier because we can simply say, instead of passing a whole bunch of parameters, we can say printf, and we can do a couple of backslashes, and we say student, and print some more asterisks to kind of separate our output. And then we do another printf, and this time we start displaying everything that we have. So we can say first, and we say student first name, another printf, and this time last name, and we say student oh, I'm going over here crazy with my page up and page down. Sometimes I miss the arrow and hit page up. So let's say, okay, and then we want to do the age. And this time we do a %E, and we say student age. And we can do one more, and we can say the GPA. And we can say %F, and pass it the student.gpa. And we want to format the age. Normally you want to format all your floats, so this time we want to display just one decimal point. So we say student GPA. So that looks about right. So we have print student, we have parse student, we have a struct to hold our student, and so it looks like we have everything. Let's see if this actually works. Okay, so we have student, we have display, and so very easy. We already have student, parse student, display student, and then we close our file. Will it work? I usually make mistakes, so it wouldn't surprise me if it doesn't work, but I like to show how I work, and I like to show how I find my mistakes, because believe me, you will make mistakes when you code, and finding the mistakes is a big benefit. So let's go ahead and try to run this and see what happens. I think, let's see, I got all my libraries, so I have that. Okay, so let's go back over here. Let's clear our screen. Let's compile, and gcc-o, the name of my exe, rf.exe, and then my main.exe, because that's the file I want to compile. Oh, wow, look at that. It compiles first time go. Wow, I'm proud of myself. So let's go ahead and take and read the file. And what happened? Did it not compile? What do we do? Okay, contents of file, reading file. It read the file. It didn't display as I expected it, so why didn't it? Did I not call something? Student, parse student. I am in the right file. Ooh, I didn't save my file. Not so proud of myself anymore, huh? So let's see, maybe it won't even run this time. So let's go ahead and save it. And let's go ahead and try it again. Oh, I did make mistakes. So let's see, let's go one by one. Warning, passing argument in string talk discards const qualifier. Oh, what did I do there? String talk. So, what line was it? String talk 18. Let's go to 18. I did something with string talk. String talk, line, delimiter. What doesn't it like? see. What does the file say? Passing argument one of string that discards const qualifier from pointer target. Oh, basically it's telling me that that it discards it because I didn't have the const. So let's see if this works. So we have that. Let's check for any other errors. So expected char, but what arguments have const char? Okay, so that's C2. Oh wait, and file included from C2 const char. Oh, it's still complaining about char. It's about string talk and doesn't like that. Let's see, maybe it'll run this time. So we saved it. Let's try it again. Ooh, what did I do here? String talk, main, implicit declaration function, display student. Oh, I have the wrong name for display student because I changed it. I said parse student, then I changed it to display student. And so I need to say parse student here. Let's save this and try it again. String talk, main, incompatible type for argument, parse student. Oh, I'm just making so many mistakes. Oh, wait a minute. This is print student, not display student. Print student. I need to slow down and to really take a look at this. So parse student is the line. I had that right. I had display student instead of print student, and I called it parse student. So it should be right now. So let's go ahead. We already have it saved. Let's go ahead and try it again. This time we have another mistake. So let's see, warning, passing, discards const qualifier, passing argument one, string tongue, line, delimiter. Doesn't like that. But that's not my error. So what is my error? Expected char, but okay, so maybe that is my error. In function, parse student, warning. 2. Expected char 1. Okay, so it says that I'm passing it a const, but it expects that. So let's fix that because I think I have that wrong. So let's go back to string talk. And yes, it doesn't like that. It wants that. And voila, it compiles. So now let's go ahead and run it. And you can see that I display my data. And I'm not cheating because I don't have the other data now that I'm displaying. So it reads the student CSV. If we were reading from file CSV, so we don't have Beth. If we were to do the other file, see if we do the other file, you see that Beth shows up. Ooh, it it read one extra line. And you can see it still worked. It didn't complain, but I think I know why. I think it's because the line length was not long enough. So I should probably be checking for line length, but that I can leave that exercise up to you. And I think my data is because it has another line here. So oh, see that it has some blank lines. So if I was to just leave it like this, let's see if it works out. And there it is. I had an extra line is reading it. Just things that you have to take into account when you read files. You have to take that sort of thing into account. So there it is, reading file. And so if you like this video, go ahead and subscribe. If you don't like it, you can give it a thumbs down. If you like it, give it a thumbs up. But if you do give it a thumbs down, let me know why in the comments, and I can work to improve. Also, if you have any questions, go ahead and ask the questions below. And one thing to keep in mind, I post all of the source code with the video. You can find the link in the video description. It will be in GitHub. And if you click on it and go to GitHub, you don't even have to know how to use Git. You can just download a zip, unzip it, and you have all the files. And not only do you get that, but you get everything I've done up to this point. You get all the C source code that I've done up to this point. So thanks for watching. Until next time.